Hey everyone, let's continue with the chapter 9 notes. This is page 3, still on 9.1. Once you understand what the R value, the correlation coefficient, tells you, the next thing is to decide whether or not that value is high enough to be significant. So is the correlation statistically significant? How do you tell, right? How high does the R have to be? 0.8, 0.7, 0.9, I don't know. There's a table of values that you can use to decide that. It's called the Pearson correlation coefficient table. It can be found in Appendix B. It's called Table 11. So what you basically do is you use two factors, a level of significance and the sample size, and that will lead you to that critical value. And then if R is bigger than that, then it's statistically significant, okay? And we're using absolute value of R, so if absolute value of R is greater than the critical value, in other words, if your R value is negative for finding the critical value, just ignore it, okay? So if it's bigger, then there's enough evidence to conclude that there is a significant linear correlation between the two variables. Okay, so let's try this out. Let's find the critical value in the blood pressure example. So in that blood pressure example, if we go back to it, we had 10 men. So that's the N. So I want to jot that down here. N is 10. And then we also have this level of significance of 0.05. Okay, those two will lead you to the critical value. So if I jump to the table, you should have access to this table through Canvas, or you can get it through MyMathLab. It's in the textbook. So you might want to have that out so you can follow along. So let me jump to that. So here it is, table 11, critical values for the peer. So don't worry about this one. Pearson correlation coefficient, it's this one. Okay, so we've got C as 0.05. Not sure why I was calling that C, that's alpha. I'll change that. Sorry about that. I was thinking about confidence levels back from chapter 6. Flashing back, I guess. But it's an alpha level of significance. Oopsie. Okay. 0.05 is alpha and N is 10. That leads me to my critical value of 0.632. See, really easy table to use. You'll only be given two alphas. It's either going to be 0.05 or 0.01. If it's a different one, we can't even use this table or do this problem, so you won't see anything different besides those two, okay? So 0.632, I can jump back and finish the problem. Okay, there it is. Let me one slow adjustment there. There, now that's better. Okay, now what I'm doing with this is I'm comparing it to the R we found, and we already found that on the last video. If I page up, there it is. R is 0.9083. So just let me put that here, 0.9083. And notice that that's bigger, right? So 0.9083 bigger than 0.632. And if that's the case, there is enough evidence to conclude that there is a significant linear correlation. So I could just say the correlation is significant. In other words. Okay, and that's it. Not too bad. Let's try a brand new example. Here's one with soccer players comparing max weights of squats to time in seconds running a 10-meter sprint. Okay. First thing I got to do is find the sample correlation coefficient R. And of course, not doing that by hand, doing that with StatCrunch. So let's jump back to StatCrunch. There's the table. Go here. And this set of data is in your groups folder in StatCrunch if you wanted to try it out on your own. But there it is. I have the data loaded. And anytime you're doing anything in StatCrunch for Chapter 9, you're pretty much going to one place: stat, regression, simple linear. Okay, so that's what I want to do. Max weight is the X variable and time is the Y. And that's all I'm really going to do right now. Compute. And then there we have it. Lots of information for the output. I'm looking for the R. There it is. Negative 0.9825. Okay. So that seems pretty high. It's pretty close to -1. Indicates that there is a strong negative linear correlation here. That will be part B, right? Describe the type of correlation. I would say strong negative linear would be my adjectives. All right. And then we want to decide if it's significant. Probably is because it's so strong. But to verify that, let's use that table. Right? And that would be part C. For a level of significance of 1%, is the correlation coefficient significant? Okay, so I'll just, while I have this up, I'll jump to the table. Here, we had 12 soccer players. So I'm going to 12, and then I'm doing the 0.01, and that's 0.708 for my correlation coefficient. Okay, so let's jump back to the handout and finish this page off. If I'm thinking about that part C, I'm comparing 0.708, what I just found on the table, to the absolute value of R. So in other words, just drop the negative 9825. And yeah, the 9825 is bigger, so it is significant. However you spell it. That looks like significant. What did I do there? Let's make that better. Significant. Cross your F. Okay. I didn't write in for part B, but I did say it. It's strong negative linear. And I'll rewrite these to make it look nicer for the printout. Okay, that's about it. I think that's a good point to stop because that's the end of 9.1. So I'll start a new video for the next page, starting with 9.2. Hope all is well. Talk to you later.